Good morning and welcome to the next lecture of this video course on advanced hydrology. In the last class, we looked at how to calculate or estimate the precipitable water in a static atmospheric column. We derived the associated equations. We also looked at how the pressure and temperature varies with respect to height as we go up in the atmosphere. Then we looked at the mechanism of formation of precipitation, and we said that there are two basic physical mechanisms that are required for rainfall to form in a cloud. One of them we said is the lifting of an air mass of moist air, so that when an air mass lifts up, its temperature goes down, it cools, and due to that cooling of the temperature, the moisture condenses, all right, and in the form of tiny droplets, the water vapor becomes into rainfall. The other mechanism we said is the nucleation, which is the condensation of water vapor on the nuclei or aerosols or small particles, very tiny particles which are present in the air. With this, what we would like to do today, we will get started and look into the dynamics of a cloud, what actually happens inside a cloud, all right. So, what I would like to do is draw your attention on the board. We will come here and look inside a cloud. So, what we have is, let us say this is a cloud, okay, and one of the things we have said is that there is lifting of the air mass is necessary. All right. So, air mass gets lifted into a cloud, and then let us say that the nuclei are present or the aerosols are present in them, and then what happens, all right. So, if we look at the mechanism, how it gets started is, the droplets form by nucleation, or aerosols or on aerosols or nucleating agents which are of the size of the order of 0.01001 to 10 micrometers. We said that yesterday. Okay. After that, what happens is, some of these droplets increase in size by condensation or by further condensation. All right. So, we have this two basic mechanisms, lifting of the air mass, presence of nuclei or aerosols. So, small tiny droplets have formed, and after that there is a lot of activity that takes place in a cloud, all right. So, this droplets will increase in size due to further condensation. Then the droplets become heavy enough to fall or to start falling. This is of the order of 0.1 millimeters. So, what happens is that the air mass is getting lifted, droplets are forming, and then these droplets of water are increasing in size, all right, due to further condensation, and what happens then is they are just floating in the air, all right. Due to further condensation, they become larger in size and they become heavy enough to start falling through the air. Okay. After that, you may have some droplets increasing in size further. How? By impact and aggregation. Okay. What do we mean by that? 2 or 3 more drops can combine and aggregate to form a bigger drop. All right. It is not exactly condensation, but due to impact and aggregation, 2 or more drops can combine to form a bigger drop. Okay. And then they start falling more quickly. Okay. From here, what may happen to some of them is many droplets may in fact decrease in size. This is different. May decrease in size. How? By evaporation. Okay. So, within the cloud you see that there is a lot of activity taking place, there is condensation, and at the same time there may be some of the drops getting evaporated back into the water vapor form, all right, and these size of these drops will then become smaller. And then from here you see that when the droplets become heavy enough, they start falling through the atmosphere onto the ground, and that is when you say that raindrops of size approximately 0.1 millimeter to 3 millimeters will be falling on the ground. All right. While it is happening, you may have the larger drops breaking into smaller one. Breaking into smaller ones, and then some of them can combine again to become heavy enough to fall again, and from here some can go to this size, some can go to slightly bigger size, and so on. So, you see that there is a lot of activity that is taking place inside a cloud. Okay. So, just to rephrase, you have two basic mechanisms, one is the lifting of the air mass, other is the presence of nuclei, that are those two are required. Once that happens, there is lot of activity taking place, and ultimately what we see coming out of a cloud is the rainfall of approximately this size. This will keep falling. Later on today we will see how the rainfall actually, these drops of rain will actually fall. All right. We will look at the forces that will be acting on a raindrop and how actually it will be falling through the air through what is called a terminal velocity. All right. So, now we will come back to the tablet PC and continue further from here. Okay. So, what we will do next is we looked at the formation of the precipitation or formation of the rainfall in a cloud. Now, what we will do is we will look at the forms of precipitation. What do we mean by the forms of precipitation? Means the precipitation is a general term, it may include rainfall, it may include snow, it may include hail, and so on. All right. So, there is a general term called precipitation, and the precipitation can be in many different forms. So, what we will do is we will look at various types of precipitation that can occur on the land. All right. All right. So, we will start with what is called drizzle. Which are nothing but the tiny liquid water droplets which are of the size about less than 0.5 millimeters. Okay. The intensity of the drizzle is less than 1 millimeter per hour, that is the rate at which the drizzle is falling. The settling velocity or the terminal velocity or the fall velocity with which the drizzle falls on the ground is very small, very low. It basically appears to float. Okay. So, I am sure all of you have experienced drizzle. Drizzles are it's a very small tiny droplets of water just falling through or just floating through the air, all right, and they cannot be measured, they will not be they will not be able to accumulate in any rain gauge, all right. So, it will be just very little traces, all right, and when the size of the drops become higher, that is when we have what is called rainfall or rain. So, that is the next form of precipitation is your rain, which is classified as the water drops of size 0.5 millimeters up to 6 millimeters. And remember that when we are talking rain, it is liquid form of water. The rain may be classified into 3 different kinds depending upon its intensity. If the intensity of rainfall is between 0 and 2.5 or up to 2.5 millimeters per hour, it is called or characterized as light rain, all right. And if it is between 2.5 and 7.5 millimeters per hour, we say that the rain is falling at a moderate intensity or it is a moderate rain. But when the intensity of rainfall is more than 7.5 millimeters per hour, then we say that it is heavy, all right, rainfall. So, this is the 2 different forms of rainfall, not rainfall, I should say precipitation, drizzle and rain, all right. Continuing further, the next one we have what is called the glaze. Okay. Some of these you may not have experienced, but may have heard about them. Is, let me first define it. Is the ice coating which is generally clear and smooth, which is formed on the exposed objects or surfaces. By the freezing of supercooled water that is deposited by rain or drizzle, which we have just seen, the rain or drizzle. Okay. So, what is a glaze? Is it is an ice coating which is formed on the exposed objects or surfaces which are outside, all right. It may be the top of the cars, it may be tree leaves, it may be anything lying outside. So, what happens basically is as the rain or drizzle is falling, it falls as liquid water, and then once it comes in contact with a very cold object which is outside, then it suddenly freezes into ice coating or some kind of solid which is called glaze. So, you see that glaze is a phenomena which actually occurs on the ground, not in the air. Okay. So, it is important to understand that. The specific gravity of that ice that forms is of the order of 0.8 to 0.9. Okay. Moving on, the next form of precipitation is what is called a rime. Rime is a white, opaque deposit of ice granules, which is more or less separated by the trapped air. and formed by rapid freezing of supercooled water drops impinging on exposed objects. Okay. So, what is rime is? It is again a phenomena that occurs on the ground. Okay. In this case, you have the liquid water falling and coming into contact with the exposed objects on the ground. All right. However, in this case what happens is there is lot of air that gets trapped while the water is getting frozen into solid. Okay. And because of that air that gets trapped, the whole coating of rime is opaque, you cannot see through, and it is whitish in color. Okay. So, the difference between the two, the glaze and the rime, is that glaze is more gradual process and rime is a little rapid process in which the air gets trapped. Now, if I ask you what will be the specific gravity of rime, what would your answer be as compared to the specific gravity of glaze? Well, as you know, as because the air is getting trapped inside, the specific gravity has to be lower. Okay. So, it is in the range of 0.2 to 0.3. Okay. The next form of precipitation we are going to look at is what is called snow. I am sure all of you know or understand or may have seen, at least some of you, what is snow. Snow basically consists of ice crystals. So, it is a solid form of precipitation that is actually falling through the atmosphere. So, it consists of ice crystals which usually combine to form the flakes or the snowflakes. Okay. So, it is a solid form of precipitation in which the water is falling in the solid phase in the form of ice crystals or snowflakes. All right. Now, snow also, those of you who may have seen snow occurring, it can be of two different kinds. Okay. What are those two? Well, in one of the kinds you will see that the snow is falling like some flakes or like cotton, very light, just floating through the air. All right. That will come close to the ground and it will not accumulate. The other kind is like sand particles. All right. The other snow is like sand particles which will tend to accumulate as it falls on the ground. All right. So, you can say that it is of two types. All right. One of them is like cotton. All right. It just appears to float and it will not accumulate. It will just melt by coming with contact on the ground at any object. Will not accumulate. Okay. So, you cannot measure it. When we say snow is 2 inches, that is not the cotton type of snow. All right. The other one is like sand particles or like sand, which tends to accumulate. That is the real snow we refer to when we say the snowfall in the Himalayan region was 2 inches, 4 inches or a foot or whatever. Okay. And as you all know, in India, where do we get snow? Okay, mainly in the Himalayan regions or hilly areas. Okay. All right. So, that is about the snow. The next form of precipitation which we are going to look at is called hail. Okay. What is hail? Well, hail is very dangerous form of precipitation. Okay. It is like ice balls. In Hindi we call them ole, ola vrishti. Okay. So, it is the most dangerous form of precipitation in the form of ice balls of various shapes and sizes, all right, and this size is generally is more than 5 millimeters. So, this is a sufficiently large size of ice balls or ice crystals. They can occur in many different forms. Normally, it may be spherical, or but they can be very irregular also when it is falling very quickly due to the dynamic climatic conditions. Okay. When I talk about this hail, well, it is very harmful, of course, I should say, dangerous and harmful form of precipitation, of course. Okay. I like to give an example of the largest hailstorm on record, all right, anywhere in the world. Okay. So, just to give you an idea of how dangerous it can be, all right. So, the largest in terms of size hailstorm on record, historical records, is in the US, all right, and it was in Coffeyville. Coffeyville is the name of that town in Kansas state in US, and this hailstorm occurred on 3/9/1970, okay, long time ago. The ice balls or the hails that fell on that day had a measured circumference of approximately 44 centimeters, okay, the circumference of the ice ball, all right. Can you tell me what will be the diameter? Well, diameter is 2 pi d. So, if you can calculate the divided by 2 pi or pi d. So, you can divide it by pi or 2 r. Let me see, it will be approximately 14 centimeters, okay, not exact, but about 14 centimeter diameter ice balls. Can you imagine how big it is? Well, it is the size of a football, all right. So, that is the kind of hailstorm that can actually occur, and it can do lots of damage, not only to the fields and agriculture sector, but also to the life and property of the people. And on that day, the weight of each ball was of the order of or approximately 7 kilograms. So, almost 1 kilogram balls. Okay, so, moving on, I would like to look at the next and probably the last form of precipitation, which is called sleet. Okay. The sleet consists of transparent, globular, solid grains of ice formed by the freezing of raindrops or refreezing of largely melted ice crystals. Falling through a layer of subfreezing air near the earth's surface. Okay. So, what is sleet is? Sleet is a phenomena again that occurs in the atmosphere, not on the ground. So, it is not like glaze or rime. So, it is, but it is not more like snow or hail. Snow or hail forms very high up in the atmosphere, okay, and then it falls very quickly. But sleet is something that that is, the liquid water is falling, and the very close to the ground there is temperature is very low, and due to that it freezes very quickly close to the ground, all right, and then it will consist of a sheet of ice coating on the roads or on the objects, and all the exposed objects outside, all right. Sleet is again very harmful because all your traffic will be standstill, you cannot drive, you cannot walk because of the sleet coating or ice coating on the roads and footpath and everything, okay. So, this is also quite dangerous form of precipitation, okay. So, with this we see that there are many kinds of or forms of precipitation which will occur in different climatic conditions in different places or at the same place in different types of conditions, all right. So, moving further, what we will do next is look at the precipitation characteristics in India, but before I go to that I would like to look at what is called the artificial rainfall. Remember, we looked at the two different mechanisms of formation of rainfall. One was the lifting of the air mass, another one was the presence of the nuclei, okay. But many times what happens is, we have the air mass lifting, all right, there is a moisture in the atmosphere, but it does not rain. It happens in some arid areas due to the non-existence of the nucleating agent, all right. So, what people and many researchers have tried to do is, they have artificially tried to inject the nucleating agents into the clouds, all right, because there is no nuclei. So, the condensation of the water vapor does not take place, all right. So, artificial rainfall is nothing but is a process of artificially nucleating the clouds to induce precipitation. Okay, by injecting these nucleating agents into the cloud, and many kind of techniques or methodologies have been adopted mainly in the US and other western countries to conduct these experiments, in which the aircrafts are used, the hot air balloons have been used to inject these nucleating agents into the cloud, and it has resulted into some success, not very big success I would say, because there is a lot of money that was spent in the early 70s and 80s, and the increase in rainfall in those arid areas was very minimal, it was less than 10%, and the cost associated with the artificial rainfall is humongous, okay, it is too much. So, the benefits were not seen to be very large, all right. So, that is why we do not have artificial rainfall being practiced very popularly anywhere. Anyways, what are these nucleating agents is, the most popular which have been used is what is called the silver iodide. Okay, and also the dry ice, the frozen carbon dioxide, the dry ice has also been used, and there are many other types of nucleating agents. Okay. All right. So, we will leave it at that. Those of you who are interested in looking at artificial rainfall can go through some of the resources on the internet. It is a very interesting phenomena, of course, no doubt, but it is very difficult to practice and perfect. All right. Okay. So, moving further, what I would like to look at is, I will pose a question to you actually, which is very interesting. Why does the solid form of precipitation form in the atmosphere? Okay. In the atmosphere, you have water vapor which will condense, all right, then it will be either liquid or solid. Ice crystals will be there, the liquid water will be there, the water vapor will be there, all right. Sometimes only the rain falls, the liquid water falls, and sometimes you have the solid water or the ice crystals forming. Why do these snow or hail or ice crystals form? All right, and let me pose this question to you, maybe slightly more technical manner. In the sub-freezing temperature, well, we know that whenever we have solid form of precipitation forming, the temperatures are very small. They are sub-freezing, means below 0 degree centigrade, right. So, in the sub-freezing temperatures, in a mixture of ice crystals and liquid water, we are talking droplets, evaporation of water droplets takes place. And the evaporated water then condenses on ice crystals. That means the ice crystals grow in size. Grow in size to become snow or hail, depending on the size and conditions and so on. Okay. Why? Why does it so happen that when you have mixture of ice crystal and liquid droplets in the air, the mass transfer takes place from liquid to solid, all right. That is when the hail is formed or the snow is formed, or the size of the solid water increases and we have the hail falling. Okay. Why does that happen? All right. So, there is the liquid water gets evaporated, and that evaporated water quickly condenses onto the ice crystals and they grow in size. Okay. Why does that happen? Think about it. The answer lies in the saturation vapor pressure of solid and liquid water. All right. So, if you think about it, the reason is that the ESAT or the saturation vapor pressure over ice is less or more than the ESAT over the liquid. Well, the temperature over the solid will be lower, and if the temperature is lower, the saturation vapor pressure would be obviously lower, right. So, the saturation vapor pressure over the ice crystals is less than the saturation vapor pressure ESAT over the liquid water. All right. It is because the temperature over ice is smaller or less than that over liquid droplets. Okay. So, it is basically it is a natural phenomena or mechanism in which the mass transfer takes place from higher energy to lower energy. All right. The saturation vapor pressure over the liquid droplets is higher, and saturation vapor pressure over the solid or ice crystals is lower. That is why the transfer of mass takes place from droplets, water droplets towards the ice crystals during the formation of the this hailstorm and snow. Okay. However, for all of this to happen, the favorable conditions have to be there. Okay. So, it is an interesting aspect. I thought I will take it up before we move on to the monsoon characteristics in India. Okay. I would not like to go too much into the detail of this, but the next thing we are going to look at then is what is called the precipitation characteristics in India. All right. So, we have looked at so much different forms of precipitation, but whenever we talk about precipitation in India, we just talk about rainfall. Okay. In most of the country, all we have is the liquid precipitation in the form of rainfall. All right. Most of our country is dependent on this rainfall for various needs, as I have said earlier. However, in very small regions in the Himalayan regions, we do have solid form of precipitation, but that does not contribute probably too much to our economy. Okay. So, first I will define there are 4 different seasons which have been characterized by the India Meteorological Department or IMD, all right, or from hydrological point of view, we have 4 seasons. One is called the southwest monsoon, which runs from June, as you know, to September. Okay. June to September is called the southwest monsoon. Second one is called transition 1. Which is also known as the post monsoon, which is from October to November. Okay. The third one is called the winter season or winter, which runs from December to February, and number 4 is what is called a transition 2, which is also known as summer, which is during March to May. So, you see that the whole year is divided into these 4 different seasons as far as the studying the precipitation characteristics in India is concerned. Now, these seasons are probably will not match with the season as you know, but these are as far as the hydrology is concerned. All right. So, what we will do next is we would look at the southwest monsoon in India. Okay. So, let us move on to that. Okay. So, let us look at the southwest monsoon in India. That is the only one we will look at out of those 4 we have seen. Southwest monsoon, and which runs from, as I just said, June through September, these months. Okay. And commonly it is just called monsoon. Okay. Those of you who do not know, there are 2 types of monsoon in India. One is just called actually the monsoon, which is in fact the southwest monsoon. All right. This other one after this monsoon, which is concentrated mainly in the southern part of the India. We will not concentrate much on that, because majority of this rainfall which we receive is during the monsoon season in India. So, before we actually go to the dynamics of the monsoon in India or the southwest monsoon, I would like to just look at some basic facts about this or some interesting numbers about this monsoon in India. About 75% of average annual rainfall. What is AR? It is the average annual rainfall which is received over the majority of the country or India is during the monsoon months or during the monsoon season. Okay. That is June through September, June, July, August, September, these are the 4 monsoon months. So, you see that the majority of the rainfall, almost 75% of the average annual rainfall is received during the monsoon. So, you see that the rainfall is very unevenly distributed with respect to time in India, and we will see later that it is also very highly unevenly distributed over space also. Okay. The western part of Rajasthan and Gujarat, as you know, are very deserted, all right. They receive very little rainfall, and some of the places in the northeast like Cherrapunji and some other northeast regions, they receive maximum amount of rainfall actually in the world, all right. So, the distribution of rainfall is highly uneven with respect to space, but with respect to time also, all right. We receive most of it. So, managing the water resources in India, it becomes a very big challenge, all right. So, we will not go into the details of that, but we will just look at some of these numbers. Okay. What is the rainiest month? It should be very easy for you to guess. It is July in most places or most parts of India. Okay. In July, you receive most of the rainfall out of these 4 months in most parts of the country. The monsoon originates, where does it originate? In the Indian Ocean, as you know. And where does it appear first? Where does it appear first? Well, today is 2nd of June, the day on which this lecture is being taken, and I just heard that the monsoon has just arrived in Kerala, all right. So, the first place in India where the monsoon arrives is Kerala, all right. It first appears in Kerala, the southern part of our country, by the end of May normally. Okay. And then this monsoon is accompanied by southwest winds, all right, of the order of or at approximately 30 to 70 kilometers per hour. Okay. So, I will look at that again, looking at some numbers. The rainfall which we get, I was talking about the spatial variation of rainfall in India. In Assam and the northeast region, they receive about 200 to 400 centimeters of rainfall over the whole year. These are on an average numbers in different places in Assam and northeast. The west coast, including Mumbai, the rainfall is of the order of 200 to 300 centimeters. The West Bengal and close by areas, the rainfall is small, of the order of 120 to 160, but nonetheless it is close to the average rainfall. In UP, Haryana, Punjab, the northern belt, it is slightly less than average, about 100 to 120 centimeters, all right. And what is the average annual rainfall of the whole country? I do not know if you know, it is of the order of about 120 centimeters. Okay. So, for the whole country, the average rainfall is about 120 centimeters, okay, in a year, and you see that this is the distribution of rainfall with respect to space, and we have seen that this is very highly uneven. You have a lot of rainfall in some places and very little rainfall in the other. So, that is why we have the problems of floods and droughts. At the same time, we may have droughts in one part of the country and other parts of the country may be experiencing floods. Okay. Similarly, we have lot of rainfall, lot of water available in one particular place due to the highly uneven distribution with respect to time, all right, during these 4 months, but we do not have water for our needs the rest of the year. Okay. What I would like to do next is look at this southwest monsoon wind patterns, all right. How does it actually contribute rainfall over the majority of the nation. Okay. As we said, there are monsoon winds, okay, which are responsible for bringing the moisture from the Indian Ocean, all right, onto the land masses or over the country that is India, all right. So, these monsoon winds have two branches, okay. You may have studied this earlier, right. One is called the Arabian Sea branch, okay, and other is called the Bay of Bengal branch, coming from Bengal. The wind patterns. The Arabian Sea branch of the monsoon winds, it starts in Kerala, as I just said, and then it travels before I go to that, during approximately first week of June, that is when it starts. Then it travels to the north, goes towards north to Karnataka, Maharashtra, Gujarat, and then finally it reaches the central portion of Delhi around the 4th week of June. Okay. So, this is the slight pattern if you want to see or look at of the Arabian Sea branch. It goes through these parts of our country and reaches the central portion or Delhi around 4th week of June. What happens to the other branch? Well, it starts in Assam, when around the same time, first week of June, okay, as the Arabian Sea branch, which starts around the same time, first week of June in Kerala, all right. So, the Bay of Bengal branch starts in Assam in the first week of June, and then it goes through or comes through the northeast region to Bihar, through UP, right, and other places, and then this also reaches the central portion Delhi around same time, 4th week of June. Okay. And then what happens is these two branches of the winds are coming toward the central portion of our country, and then they formulate or they combine to form what is called a monsoon trough. It's a low pressure zone. It's called the monsoon trough. So, if I did that, you have monsoon trough. Okay. And what happens then is this monsoon trough starts oscillating over the country, all right, for some time. Okay. It will be travel up and down, it will be bringing, so it is like a steady and unsteady process. So, the moisture is coming from these two branches, from the Bay of Bengal and the Arabian Sea branch, all right. So, they bring the moisture onto the country. This monsoon trough will be oscillating and its movement will dictate the kind of monsoon we will have on a particular year. So, it is very highly dynamic, the monsoon trough, and how it withdraws back into the two different branches will also dictate the withdrawal of the monsoon. Okay. So, let us look at this slightly more technically. What is a monsoon trough? It is a low pressure region is formed between the two branches when they meet. Which is called the monsoon trough. The monsoon patterns in India is determined by the movement of this monsoon trough. And then the withdrawal of monsoon, which is marked by substantial rainfall activity starts in the withdrawal, that is September in the northern part of the country. Okay. So, withdrawal also starts from the northern part of the country. So, you see that the monsoon is formed by these two different currents that come from two different places. One is the Arabian Sea branch, other is the Bay of Bengal branch. They come and meet around the same time in the central portion, and the oscillation of this monsoon trough basically dictates the monsoon pattern in India. So, this is about the different seasons and the monsoon in India. The next thing which we are going to look at, we had seen the formation of the raindrops in the atmosphere. Okay. So, what we will do next is how the drop of rainfall actually falls through the air, all right, and what we will do is we will derive an expression of what is called the fall velocity or the terminal velocity. Okay. So, that is the next thing we will do. Is what is called the terminal velocity of a raindrop. Okay. So, I will first draw the figure. Let us say this is your raindrop. I have drawn a big sufficiently large sized raindrop, and I am marking some of the forces that are acting on it. Okay. So, what we will do is we will look at the spherical raindrop and we will analyze the various forces that are acting on it, all right, and then we will balance these forces, and once we balance we will be able to find out what will be the fall velocity. Okay. So, if you want to look at what are the forces that are acting on a raindrop when it is falling through the air, we will say that there are three forces acting. Gravity is acting downwards, there is buoyancy or buoyant forces acting upwards, there are drag forces acting upwards. Okay. So, this is your F of B acting upwards, this is your F of G, and this is your F of D. Okay. All right. So, I think I may not have time to complete this, but what we will do is let's say that the diameter of this spherical raindrop is, let us say, D. All right. So, this one is D. So, what I would like to request you is you look at this as a free body diagram. You have three forces acting on a spherical raindrop, and then you try to find out the expressions, or you write these three forces that are acting, that is gravity, buoyancy and drag forces. And then when the raindrop starts to fall, initially it starts from 0, but after some time when the forces will balance, it will start falling with a constant velocity. So, initially it accelerates, but after some time it attains what is called the terminal velocity or the fall velocity. All right. So, you think about what will be these expressions, and we will come and look at them in the next class.